Hello class, today we're going to talk about specifications. So I will first introduce a set of very important concepts that you should be able to identify. So the control limits, as we have learned so far, are established as a function of the average, right? So we use the dashed lines, the dashed curves, for the distributions and the control limits for the averages. And we use solid lines and solid curves for the individual values. So the specifications are the permissible variation in the size of the part and are therefore for individual values. Okay, so the USL and the LSL is the upper specification limit and lower specification limit. And these specifications are established by design engineers to meet a particular function. I want to emphasize that the control limits and specifications are obtained independently, so they do not have any correlations between each other. The process capability and the tolerance are defined for the individual values. So the process spread, this 6 sigma, will be referred as to the process capability. This sigma is the population standard deviation for the individual values. And the tolerance is defined as the difference between the specifications. So the tolerance is the USL minus the LSL. As I mentioned, the specifications are determined by the design engineer. So if this tolerance is established by the design engineer without regard to the spread of the process, without regard to the 6 sigma, then the undesirable situations can result. So here are 3 situations that are possible to compare the process capability and the tolerance. Case 1 is that the process capability is smaller than the tolerance. Case 2 is the case when these two values are equal. And case 3 is the case when the process capability is greater than the tolerance. In the first case, the process capability is less than the tolerance. So this one is the most ideal situation. Every product in my process is within the upper specification limit and the lower specification limit. So every product is qualified. And because I have some space between my control limits and the USL, or also the lower control limit with my LSL, so it even has some flexibility of shifting my process. Even my process is shifted a little bit, then the out of control point will still not be wasted because it's still within the tolerance limits. In case 2, the process capability is the same as the tolerance. So here's a typo, it's not less than, it's the same as the tolerance. So as you can see, the 6 sigma and the difference between the USL and LSL are the same, right? So in this case, if the process remains in control, then there will be no non-conforming products. However, whenever you shift your process, then there will be some non-conforming products. So you have to waste some of your products. In case 3, when the process capability is less than the tolerance, then the process is in control, but still there are non-conforming products, right? So even your process is in control, you still have to discard some of the non-conforming products. So this means the process is not capable of manufacturing a product that will meet the specifications. In this case, if you shift your process, then there will be a larger portion of the non-conforming products.